Hi, we are Group 19 and our project is the improvement and validation of Smart Lock MVP for European market. Our group members are Haolin Xin, Yihan Zhu, Zhiqing Xing, Yiming Wang, Xiao Lu. Our instructors are Yin Mat from Bosch and Professor Payson Huang from JI. Our project is inspired by the phenomenon that in recent years, the rising burglary rate raises people's concern about safety. Police recorded 306 burglaries per 100,000 inhabitants in the EU countries in 2022, an increase compared with 284 in 2021. The number of burglaries increased by 7.4% compared with 2021. Furthermore, the cost of upgrading home security systems with modern technology is prohibitively expensive for many. This significant expense discourages many from opting for professional installation services, leading to a trend where homeowners in Europe prefer to install lock bodies on their own. This do-it-yourself approach, while cost-effective, underscores the necessity for digital locks that are not only secure but also user-friendly and easy to install without professional assistance. To address safety issue, our goal is to design a smart lock that can remotely remind users of the door's open/close status and locking status. We came up with a status detection system which uses multiple sensors to detect all statuses of the deadbolt, the bevel latch, and the door. The Hall effect sensors includes two types, DRV5023 digital switch sensor and DRV5053 analog bipolar sensor. 4 different magnetic flux densities, DRV5023 has only 2 output states, while DRV5053 has linear output states. For both types, when the magnet approaches and the magnetic flux density reaches or is larger than the maximum operating point, the sensor's output voltage will be 0. When the magnet keeps away and the magnetic flux density reaches the minimum releasing point, the sensor's output voltage will be the maximum. In our Arduino program, these output are mapped to Boole-type values. When the sensor detects no magnet, the output always gives a 0, while when the magnet approaches, it will return a 1 value. Additionally, users can unlock the door remotely via a mini program. For hardware and mechanical solutions, we have to integrate PCB and battery into the lock body. To simplify the process of changing battery, we also designed a new battery box that opens by pressing the pop-out mechanism, which is inspired by the structure of a SIM card tray in mobile phones. It operates through a combination of a slider, guide rod, and spring. When pressed, the guide rod engages with the slider and the battery box, securing the rod within a groove to fix the battery box in place. When pressed again, the guide rod will move along the line at left, and the battery box could pop out driven by spring. Our prototype is composed of several key parts located both inside and outside of the lock body, each serving a distinct function within the system, which runs at a maximum power supply of 4.5 V. Outside part is control system based on an Arduino board, an L9110 motor driver, and an HC04 Bluetooth module, which will be considered to integrate it into PCB board by Bosch and Fertrada. The working logic shows interfaces between these components, including mechanical transmission, signal communication, and power supply, which helps us with locating components and arranging wires and power. The power for the entire system originates from the 3 AAA batteries, which supply energy first to the Arduino board. The board then manages the distribution of power to the remaining components. Our final prototype has an intricate process of assembly. After determining all the components, we use SolidWorks to simulate the assembly process. From figures, it clearly instructs the sequence we are going to assemble the lock body and where to fix all the component. Here is our demonstration. We've built a circuit and developed Arduino code where a Hall effect sensor detects the approach and departure of a magnetic field. The serial monitor provides output values of 0 or 1, indicating the open or closed status, respectively. Next, we present the deadbolt transmission. It operates deadbolt with a gear and motor to achieve inward and outward movement. Moving on to the battery box, a simple press enables the battery box to move along a slider, guided by a rod, facilitating its insertion and removal. Lastly, we have the bevel latch transmission. 2 rods, driven by a gear and motor, rotate to propel the bevel latch in and out. Thanks for watching. If you're interested in seeing more details about our prototype, we look forward to see you at the expo.